It's my pleasure to introduce Andrew Rosenberg. I've known Andrew for a long time. He's the Chief Information Officer for Michigan Medicine. And Andrew, welcome to MLHC.
Well, thank you. Thank you very much for the invitation, Brahmaji. Most of these talks are meant to give you new information, to talk about cutting-edge topics, to inspire you. This is not going to be that talk. I'm going to do the opposite. I'm going to talk about boring and dull legacy. I'm going to talk about bureaucracy. I'm going to talk about walls, mostly metaphorical ones, but occasionally real ones that get in your way. And you're not going to expect to hear a talk like this, but the point, and I hope you'll get when I'm done, is it's meant to help every single one of you. And I'll tell you why. Let me tell you the story why. Brahmaji, in his extensive introduction, missed an incredibly important gap. I'm the Chief Information Officer for Michigan Medicine. I am the head of IT, but I'm also a physician. I'm also a tenured faculty. And there's a story, and I don't know if Sachin is here, but when I came here as a research fellow, I'd already done medicine, I'd already done critical care. I hung out with a group of incredibly innovative people doing some incredibly great things at Espresso Royale Coffee. I was a tea drinker, but they let me join them. And I watched them develop great new technologies that were absolutely cutting edge. But during those conversations, I also heard them talk about IT at the health system. And they were evil. They got in the way. They would try to stop every effort being done by this very small group of innovators who were really trying to change the world, who were trying to break things and do new things. And I acquired that culture. So when I joined the faculty and I wanted to do work in the ICU that was for clinical care, for research, for the fellowship, in prediction models, which is what my area of specialty was, I had to work with these horrible people in IT because they didn't get us. They wanted to meet and have agendas and document things. They wanted to follow rules. We wanted to break the rules. And so the irony is that through a series of steps as I became a division director, a fellowship director, but then got involved in more of these large-scale IT projects, and I started working with these people, they are wonderful. They are dedicated, they are innovators. And they also have to keep the network running and the data center running, and they have to do things the right way because they have to run it for thousands of people. And fundamentally, the problem is that I am on the left side of this diagram and you're on the right side of the diagram. And if we don't understand this framework, we have conflicts. Slides will all be available to you. Take pictures if you want, of course, but I'll make all of these available to you. My job, and I'll just for a second personify IT. Sorry if you're trying to video this. I move around a lot. It's usually stay in one place, but I just don't do that. IT for a large organization is standards-based. It has to be, especially now. We use defined use cases. We try to focus on those things that meet all of your needs first, not yours and yours and yours and yours. Your needs are important, but from my perspective, I have to try to find where's that commonality. Our budgets are centralized, as they should be. And I'm going to be tangential a lot, but they all will come back to a point. It is so common that a researcher will say this: I have great news. I got a grant, and in my grant, I put money in for IT. And my heart sinks. Because I got $70,000, and I say, that doesn't buy you a thing. $70,000. I said, how many FTEs worth of work do you really think you need? Well, I need this coding, I need software. How about the QA and testing? How about the service desk education so when that software goes into production, they actually can answer questions? How about the servers and all of it? And suddenly, the heart starts to sink. And I say that not in any way to be rude or bureaucratic. It's to really point out that usually the money that's in a grant or the indirects that don't come to us, we work in more of those centralized budgets. We have defined governance. Our work tends to be very prioritized. And I made this point that a lot of our work is legacy and operations. That doesn't mean we don't do innovation. It doesn't mean we don't try to be cutting edge, but our primary job is in that area. You, on the other hand, are all these things up there. You're non-standards based. You want to break stuff. You want to try new things. You want to innovate. It's in your DNA to try to do things that are different. Your budgets are all over the place, including non-existent. We need you to do this, which, by the way, is a legitimate point. We are geared, we are supposed to help the entire work of Michigan medicine. It comes across often as clinical patient care, finance and operations, and there's a reason in terms of overall revenue and work why no matter where in any health system you talk about, you see that. But certainly for an academic medical center like the University of Michigan, it's deep in our desire to support this kind of work. And often there's no governance. So what I'm going to talk about today, the first part of this talk, is around elements of that to help you understand how to navigate. As if when I was a research fellow, I have all the knowledge that I have now then. That's the first part. And the second part will be a little bit more typical, showing where some of our examples at Michigan Medicine still speak to those themes. That's why this is the anti-keynote. This is I'm not trying to be cutting edge, I'm trying to show you the deep depth and darkness of the bureaucracy. Here's a first example. These are principles that I helped draft, and they tend to go against your work. Look at that first principle. We will begin by using existing solutions, not the new thing you're working on. We're going to look to our big legacy systems first. We're going to ask IBM and GE and Epic and Cerner and Cisco. We're not going to look to you because you have a brand new way of doing something. We're going to look at what we have. And underneath that title, I indicate why those principles are important. Again, they're not remotely to squash innovation, but we have to start with the investments we've made. In fact, it's incredibly common where we buy something for a lot of money and we use only a fraction of its capabilities because maybe it doesn't do this one thing as well as that. Maybe because you want to do something different, you just sort of being the wonderful, innovative faculty. But we have to start with existing solutions where we can. A second principle, which is incredibly more important now, please just recognize it. The issues around cybersecurity are probably the most relevant, important issues and frequent issues that I get from Marshall Runge, the head of the Michigan Medicine, and Mark Schlissel and the regents of the University of Michigan. Now, I'm giving examples from within the University of Michigan, but I know a lot of the other academic medical centers. I know a lot of other health systems. I know something about other universities, at least. They act very similarly to us. Cybersecurity, information assurance, data quality are all of primary concern. At one totally understandable point, breaches, compliance, and the money that goes into those breaches. At the other, our reputation, and you should be concerned with that as well. You should want to know that the data that you are using, the data that you are exchanging are reliable, secure, and things like that, or you will get shut down. And so we start from a principle point of view. We design for assurance, not, hey, I did this really cool thing, now take it to cybersecurity, information assurance. They will stop it. I'm going to show you an incredibly gut-wrenching example of that a little while later. And then finally, this idea around what is core? What is core IT? The reality is increasingly for you to do your work, you have to intersect with core IT. 15 years ago, and certainly beyond, you never had to. There really wasn't a core IT. But how do you do your work and not be part of our network? How do you store your data in any kind of cost-effective, secure way and not be part of either our data centers or even just use our contracts with the third parties to, at the minimum, get the cost savings? So these are principles that at first sound very legacy and in your face and cumbersome, and in some ways they are. But you want to know, what are the principles that drive your institution? These are ours. So go back to that first one about existing solutions. Here is a representation of your problem. These are our vendors. And by the way, they're all working in machine learning. They're all doing advanced analytics. They're all looking at cognitive computing and neural networks. Don't for a minute think that they're not all working in that space as well. And so when you say, hey, this really great model that has a wonderful ROC, we can predict this or that outcome, I say, well, so do all those vendors, and we already have those tools. Why and how do we connect with yours? I'm not going to give you the solution yet, and I don't want this to come across as, that's it, I'm done. Wrong field I'm in. You're in one of, and I'm going to show you some data in just a second, you're in probably the hottest field in IT right now. So the question then becomes, how do you differentiate yourself? Or if you don't differentiate yourself from the vendor, how do you differentiate yourself at least within the area that you work? At least be aware of it. And if you're not, as I'm going to give you examples, then you're in conflict with me. And I don't want that. I want you to be able to be more seamless, less friction. You need to know people. I don't expect you to read this, but this is the org chart of my organization at the top level. We have 1, 2, 3, 4, 5, 6, 7, 8 divisions. We have 8 senior directors. We have about 55 directors and managers, and we have about 940 staff. You don't have to know all 940, but you have to understand our people and our structure. So for example, one of those people up there, Aaron Dietrich, is the Senior Director for Research IT. That's in my organization. You will find other titles with research and IT in it spread throughout ours and your organizations, but you have to understand where people are, maybe people in your particular area. Some of you who are doing software design, you would want to know Brian Martin and his team, Paul Morrison and Carol Lively, because those are the directors and managers over our software development group. Now, we have other software developers scattered throughout HITS, our organization, but that's where we have a lot of that expertise. You would want to know who those people are, or someone in your organization would want to know that. You need to know your structures. Similarly, that story I told you of why we had this gap between innovative faculty and IT is that it was air-gapped. We had essentially no informaticians, and now we have a very robust, in fact, one of the larger groups in the country representing our departments and our work. These are our associate CMIOs and our CMIO. This is the group that I built up when I was the CMIO. In order to solve that problem, I remember from Espresso Royale on Main Street. We as faculty had no one to talk to who understood a lot of what I just said. I would not expect you for a minute to understand our full org charts and all of our work, but I would expect you to know Paresh Patel, the Associate CMIO for research related to our EHR, or David Hanauer, our Associate CMIO related to clinical research in MISHAR. I would expect you to potentially know the CMIO in your department if that was relevant for you, or the other experts in other departments, or how they interact with other informaticians like Karandeep Singh, whose some of his work I'll be quoting, who works a lot with Brahmaji and Almathu. These people start to know each other. So you don't have to know everyone. You need to know someone who knows other people. And if you don't, you will slow down. I can pick from dozens of examples. Let me pick one that literally just happened yesterday, and I was just on the phone about 10 minutes before I got up here. One of our associate chairs in one of our departments sent me an email 2 days ago saying, I'm having problems with IT. Can we talk briefly? Now, she and I know each other because we did our research fellowship together. And she said, I'm hesitating to escalate to you, Andrew, but I said, oh, no problem. But because it's around research, maybe you want to talk with Aaron Dietrich or Paresh Patel first. She writes back, oh, that's actually all I wanted to know. And within 2 hours, something that apparently had been taking about 3 weeks solved. Now, I don't expect everyone to know or to escalate to the CIO. That would be very inefficient. But that's, again, an example, and this was an associate chair in a department for a multi-million-dollar grant. So again, something as simple like that, and as I was talking to this associate chair, I said, I need to get to that meeting of all the associate chairs and have a lightweight version of the talk I'm just about to give to you, and you'll let me know if this talk is helpful, because then I'll modify it for our associate chairs. So you need to know these people, and we need to make the investment in those people who help your work. Similarly, you need to understand some of the efforts we've made, and this one is around data and information. We've done it in other areas, but this is a diagram of something that we actually worked on years ago, and while it didn't fully get funded and taken off, there are elements of it that are existing and growing today. This was an idea asked by our EVPMA at the time. The EVPMA is the head of the health system and medical school. Can you help a framework for analytics? And there are about 4 of us in the room, and if I was in the Navy, actually. There's a great thing. If you're ever asked to volunteer, the first thing to do is to step backward. And I think I didn't step backward fast enough. And, oh, great, thanks, Andrew. I said, actually, no, I'd love to do it because of my research background. And what we came up with was a framework that started with the use cases that captured all the various types of analytic use cases around Michigan medicine. Turns out we could probably lump that into 9 types of different use cases. Those use cases then stimulated very detailed, rich discussions with a lot of faculty and staff to understand what are the various needs that we have for quality, for basic science, for applied science, for basic discovery, for population health, for disparities of care. How do those types of analytic questions fit into a framework? And what are the common and unique elements of those kinds of questions, those types of data, those types of workflows? And from that, we developed a number of architectures. I'm going to show you why those architectures are so relevant in both abstract and bureaucratic and then very meaningful terms for you. We define specific projects. We define specific capabilities, the need for data management, master data management, reference data management, the need for data concierge and all of the elements of that, the need for data governance, something that I have still yet to see anyone really do well. And we defined that roadmap and what we would do, and elements of it now are going forward, and elements have really not been done. For example, we do not have robust system-level data governance. We do not have system-level master data management, but we do have a pretty good path towards some degrees of data virtualization, which will also stimulate more of those discussions. So we have those elements, and I'll talk about those. One of those that came out from that is this. This is a data map, a typical data stack for those of you who work in that, from the sources to the enriched data assets, including data warehouses and marts, to then specific purpose-built marts and all the analytic tools. This is just a brief representation of a variety of analytic tools. One problem, for example, I was trying to solve was the fact that I didn't know we had Tableau. I didn't know that we had Hyperion. I didn't know that we had Toad Data Point. I didn't know that we had. So part of this is, yeah, we have it. In fact, the license is free. Thank you. Things like that, which to me are relatively minor, are powerful to a new investigator trying to get started. And then there are communities of practice so that you can learn from others. Places like this tend to be rich in expertise, and we have these deserts of knowing who to talk to, because at sometimes our size, which is usually an asset, is sometimes a hindrance. You need to know where things are and who manages what. I don't know if you can see this, but there's a black line about 1/4 of the way up. The stuff above that black line is in my area of responsibility and or some degree of authority. Those are systems that IT runs. The point is, most of that is below that line. It's distributed. A lot of that makes a lot of sense, and we should have it. Some of it is inefficient and duplicative and redundant, and that's, I would say, part of just any big organization. But you or people you work with have to have some sense of that. Another version of this diagram that I don't have would show all the lines of intersection then were where this data warehouse, for example, feeds data to that data mart, and you could start to understand the data flows a little bit better, because you, in your mind, have a very good idea of what you want to do. You need to know where to go for the data, and that's an example of a high-level data map that some of us use for our conversations. We have much more detailed data maps depending on the need. I want you to study this diagram and know it. There will be 4 questions at the end. This is simply to point out that you need to understand, again, not remotely at this atomic level, but our architectures. The enterprise spanning architectures, the information architectures, the business workflow architectures. One thing that IT tends to do well, we document and we show all of that level of work. Remember my point I made earlier about we don't need no stinking documentation, we don't need to worry about the rules, we don't need, well, IT does, and we document a lot. And that's really important, because this is what professionals do before they get involved in very large, complex projects, so that we have roadmaps, we know where we're going, and it gives you an idea of where to plug in. Remember this slide, I'm going to show you how it was fundamentally critical to help a very successful, one of our more successful advanced analytic projects. But it's this kind of knowledge of where things are, who does what, that you need in order to get at sources of data, to understand where data flows are occurring, and where you need to plug in order to achieve the results that you're looking at. I don't expect you for a second to know where all of this is, but ideally, if you know what I know, you would say, hey, as I'm working on this project, where can I find some of the architectures that I can use to design the workflows and the steps 1, 2, and 3 that I need? And I'll show you, for example, how that worked out. One of the conversation points I had with the associate chair, she said, I don't even know where these decisions are made. And the reality is, and the very dirty secret, these are org charts that I created. They're not official at all. That red thing up there, it's only for discussion. It does not represent exactly how we make all of our decisions. But on the left side, those are the committees, some of which are in my organization, for HITS, how we do our own work, so that we can educate people. Oh, if you want to bring a new medical device into our environment, here is UDO and the committee that does those device approvals, and how it fits into the standards from the Technical Standards Committee, so that this will now get accepted and go onto our network. Because if you don't do it, it will not be allowed on our network. We have network access control. We now have the ability to prevent and shut off anything that comes onto our network. Now that is very heavy-handed. It's not meant to be discriminatory. It's not meant to stifle innovation. It's meant to protect our network and our assets, as any organization can or should do. So look for, or in some cases perhaps even develop, these kinds of charts to understand where things and who makes decisions. Understand the difference between I'm advising to, oh, I endorse that. I think Brahmaji's grant proposal is wonderful. Count me in, to I approve it. Approval in my book only comes when there's money attached to it. Otherwise, it's just a really good idea. And what we tend to have is a lot of confusion around, well, that committee approved it. Do they hold on to a budget? No. And then we get into these conflicts. And I'm trying to avoid that. In fact, one of those up there, I've actually put dollar signs to try to point out that's a committee that actually has some degree of approval authority because they have a budget. Sometimes they have to reprioritize money in their own operating budget. That's okay. Sometimes they're able to get a pool of money elsewhere. That's okay. Sometimes they go to the highest strategic buckets of money. That's great. But there has to be a financial decision often when it comes to actual approval. Otherwise, we're sort of endorsing. And I would say that's a bit of an Andrew Rosenbergism. It's not, I don't think you're going to just find that perfectly understood elsewhere, but that would have avoided a lot of the conflicts had we made it very clear, I'm seeking your endorsement so I can take it to this group, which will then use your endorsement to reprioritize money in their operating budget to do the thing you want. That's a bureaucrat and administrator talking to you about how it actually gets done. I would have never known that when I was starting out as a junior faculty. So those things that I talked about were the anti-keynote, the legacy, the administrative, the bureaucracy, but it's, again, I hope you appreciate the spirit in which I'm giving it. It's meant to help you understand how to navigate complex organizations. Because as this survey here shows, those top two lines, the one on the left, we, the CIOs of academic medical centers, deeply want to be investing in your work. Among those items felt to be the game-changing technologies. I actually thought IoT would be a little bit higher, but I think in part until the 5G standard isn't normalized, it might not be. I think it's going to be quite game-changing. But advanced analytics is at the top of the list of what we think really will add the most value. That's my point, again, about you're working in probably the hottest area that you could be from a CIO's perspective. Great career choice. Keep it up. Don't get demoralized when you run into bureaucrats and administrators like me. Know how to work within those environments, because you are at the cutting edge, no question. Where we want to fund our work in order to achieve value is also in this area. Again, this is a small, non-scientific survey of CIOs, but the signal is there. You're working in a very relevant area of IT, informatics, and technology. But at the same time, and I don't, again, expect you to see and understand this full diagram, but this idea of the digital disruption, the transformation, the innovation, words that we use a lot in the IT world that start to become a little bit mind-numbing after a while. If we're going to have these platforms that have patient and family experience, these platforms that use the new tools of the Internet of Things, these platforms that integrate across each other and exchange seamlessly and use data to do that, and the production of information from that data. If we're going to create these platforms, recognize that the digital giants, this is their DNA. They started at this, but we started in many cases in a very legacy kind of environment. So we have to still maintain a lot of stuff that is slow, that is not nimble, that does not change on a dime. And so one of the challenges with all those vendors that I showed you, some of them by their entire existence are more nimble in places. But sometimes that nimbleness is also an anchor. We have incredible stores of data. We have incredible workflows and deeply integrated things that some others don't. And the complexity is often where the opportunity is. So on one hand, we have this dilemma. We feel that we're competing with the digital giants and the very fast, nimble startups, and in some cases, we really are. And in some cases, that's great to have that pressure to make us change. But don't also lose sight of the fact that big, large institutions sometimes have some great opportunities as well. Again, a small sidestep. There is a nearly $200 billion corporation in the United States where I was on their advisory board talking to their CIO. And I made this offhanded joke about why we went to Epic. I said, who can find COBOL coding engineers anymore? That's why we had to move off of our mainframe. And the CIO said, we have a couple dozen. $200 billion, you are still running your mainframes? Absolutely. There's no way we could move off of those at the size that we are. So we still support a couple dozen. So, with that kind of, and by the way, they're doing some incredibly, incredibly great things with information, yet they still run mainframes. Okay. So let me move now with some of that background into a few of the examples. This is more of what you might have expected, but I want to tie a few of the examples and a few of many back to the comments I just made. Karen Deep, Brahmaji, and a few others did a survey last year to look at where we have some of our machine learning and AI projects going on. Roughly about 28 of them are actually led by principal investigators. And what you can see, which is kind of one of those cool things about being at the University of Michigan, there's a lot of collaboration of these projects, as they should, for the diversity of thought, the diversity of background to deal with complex problems, working with at least 7 other U of M schools. That's one of the powers that we enjoy at the University of Michigan, and that's deeply important to me to keep supporting that, because any one group is not going to be able to do this kind of complexity as well as many groups. And look at the funding sources. Again, I don't expect you to read it from the back, but they're all over the place. But think about that. The funding sources also demonstrate and reflect on the workflows and what things are going to be done. So there's a real complexity to where we are with machine learning, AI, more of those advanced techniques. So let me give you an example and tie some of my previous comments to it. This is the output of a 4-year project that came out of one of our groups called MCirc to predict acute hemodynamic instability. And the red are areas where that individual patient, those are about 12 or 15 patients. The red is an area where a patient is very likely to become unstable. Their blood pressure will drop, their heart rate may go up, and we'll all run into the room to try to help them out. The gray are area where the data are inconsistent and the predictive model can't work, and the green are where the predictive model is suggesting that acute instability will not be occurring. A relatively good example of machine learning. Let me take you through the story of how they got there. They started off with relatively classic techniques that many of you discuss in terms of machine learning, feature selection, classification, regression, things like that. They tried different data samples. They had some degree of prediction. They worked on it. They used contour analytics. They did the techniques that you talk about all the time with the basic systems that they had. They created a very nice stack of tools that layered on sources of information, some new tools to do annotation, curation, things like that. And some of those tools, in fact, were fairly innovative in and of themselves. But essentially, this stuff is something that you would see done in many of your types of projects. But this is what I wanted you to see. This architecture, which in the middle has a lot of what they're working on, shows how that group had to plug in to IT, whether it was for the directory services to know patients or providers, locations, whether it was the sources of data coming from our EHR, both the production system, but also our proof of concept systems. Because sometimes what you want to do, you want to try a model out, not in a production environment, so you need to know. Remember those big architecture slides I showed you? You need to understand all the types of environments that we have to say, hey, I didn't know that you have 3 different test environments that have actual patient data. That's incredible. We can try this out without hitting on prod. You need to have some degree of that understanding, or you need to know the people who have that understanding, because that's exactly what they did. They would try modeling in our testing environment so that there was no hit to production. We're not going to just let you dump models into our production environment. It's unsafe, and you know it. But we also build out a number of test environments so that people can sandbox and play around. If you don't know those exist, you would be stymied. And on the right side, they had to get other data from a variety of those data sources. Remember that big data map I showed you? Understanding where a variety of those sources are is incredibly important to know which data you want to pull for what purpose. So this architecture of their project shows how it reflects and works with the larger architectures that we've created and increasingly create. Then they did exactly what they should do, and hopefully you're doing. They said doing all this within legacy and on-prem is not fast enough. In fact, some of it is extremely expensive. We bought an IBM Netezza box to do some of these computations to do this work really well. And they migrated that work into a variety of cloud and open source solutions in order to scale it. Brilliant effort to do that kind of work. That's what that project was. And you can see underneath it those original architectures and where they moved it to be more modern, to be more nimble, to be more cost effective, to be able to scale larger. There's a sad side note to that story though, and I want to come back to that. There's the Netezza box. I think it cost us about $2 million. It is now scrap in one of our warehouses because it was not patched properly and it was hit by NotPetya. And it was destroyed. So one of the problems, again, we have is that issue of cybersecurity. That issue of everything we do, as innovative as we want to be, people look for high performance computing to do, this actually occurred because of someone who's trying to do Bitcoin mining within our environment. These are the things that I also have to deal with, we have to deal with. By the way, it happens where you are too. And that's an example of it. So do we not do innovation and do we not buy these things? Of course not. But that's one reason why we have more and more rules. Remember that second principle, assurance by design. You don't just get to do what you want to do. You have to increasingly look at our best practices for software development, our best practices for device onboarding and offboarding, our best practices for who you are, you're authenticating into our systems. Karandeep Singh, hopefully you've met him or you will. I don't know. I don't think he was giving a talk, but he's had a poster here. I took one of the items from one of his 7 best habits for implementing predictive models, and I love this because I put it in red if you can read that. He makes the point that I totally get. A lot of the work you want to do, you don't have the platform yet built into those big vendor platforms that we talked about, for example, our EHRs. And so what do you do when the underlying platforms don't allow your type of predictive modeling? Well, we have to be able to support that then. Again, here's an example from Jenna that to me is one of these great examples of both a pro and a con. Jenna's going to get angry at me in a second, but I'll try to still be okay, and then I'm going to get out of here. Again, look at that architecture idea, and again, the details are not important, but Jenna, in order to do, in her team, to do predictions of which patients are likely to get C. diff infections, a extremely resistant to cleaning type of infection that in some ways is very preventable by just wash your hands. But when someone gets it, it has a really high morbidity and even mortality. And there are enough features in our thousands of data that they're really amenable to the type of modeling that Jenna's research group is doing. And that modeling can be done outside of our EHR, but it needs to be actionable within it for that workflow to really work. Now, I think there are other ways for it to be actionable. It doesn't only have to be in the EHR. But if you want to do that modeling outside of the EHR and bring it back in, you need to understand that architecture. You need to know who to talk to so that your modeling can be done and you can get the data out from the EHR and then you can get it back in an actionable way. That's, again, that you need to know people, you need to know architectures, you need to know the committees to go to talk about it. You need to understand both at a more granular level yourself, but also the people you're working with, and they need to know what you're trying to do. That's a complex, interpersonal, social activity to make that happen. Now, the downside, this is the part that Jenna's not going to like, is I believe all of that modeling could also be done within Epic. Now, I'm not the expert, so Jenna will get up here and say, you're wrong, Andrew. But the problem is, increasingly, do we do all this work outside of our big platforms, or do we do it within the analytic models of those platforms? And I'm going to wrap this up to have a little bit of time for questions. This is an example of us using Epic to do that kind of prediction for sepsis, as you heard from some of the previous ones. And by the way, Epic and all these big vendors have more and more of these kinds of platforms. The key point is, it's in the platform, it's a vendor we already have, there's not a lot of expense frequently at all, and we can scale that to more and more and more and more items that need these kinds of tools, some of which experts like you are going to come up with. Others, there's no one working on, but they're of equal importance, and we just want to use the tools as they exist. How do I balance all of that? That's one of those tensions. And I'm going to end with this just to stimulate a thought. Again, part of these advanced analytics are also now around optical features. Here's just one example from our pathology department that has an incredible depth of expertise and in very advanced informatics and analytics, doing feature recognition with machine learning for cancer on whole genome digitized slides with ROCs in the 0.98 and 0.99. They are better than clinicians at detecting certain types of images. And you hear about it in retinal scans for glaucoma, you hear about it in melanoma scans for dermatology, you hear about it in plain film x-rays, and more and more and more. So that's pretty cool in and of itself. That's the kind of work being done here that we work with a lot. But here's the example I just want to leave you with. I'm not going to answer this. This is relatively new for me. How many of you are aware of light sheet microscopy? Please, someone, thank you. Good. Well, up until about 10 months ago, I actually was aware of it. I didn't realize it was called light sheet microscopy, because one of our faculty who's been doing it for a long time would always argue about, I need my compute and I need my massive 2 petabyte storage to be right next to each other, even though the systems weren't in some ways being maintained as robustly as we would want. Really, that person was doing very early light sheet microscopy. But here's one of our faculty, and we're still talking about trying to figure this out. So if we're going to be doing more advanced analytics on features and digital features, here's the problem. One device, a lot of cameras that are laser cameras, one study producing terabytes of information. One lab, one device, one study, terabytes levels of information. So if you take Drosophila, full map is maybe 20 terabytes. You take a mouse, mus musculus, that just suddenly came back from medical school. You're now talking about potentially something like 6 petabytes of data if you store all that data. The first answer is, well, don't store all the data. We tend to culturally never want to throw anything away. And then when we get into human types of studies, we don't even know what to do. How are you going to help me pay for that? Because you're not going to buy 6 petabytes of storage. You're not going to get a grant to buy 6 petabytes of storage. Oh, and then to replace that every 5 or 6 years. I don't know what to do about that yet. I'm going to leave you with that, but we're going to work on those things together. That's all I have. Thank you. Maybe time for a question or two.
So thank you, Andrew. I think we should probably have an anti-keynote speaker at every MLHC. It was wonderful to hear your examples. So if folks want to come up to the microphones with questions, that would be great. And then also the spotlight contributors, if they could start to kind of line up here for the next session as well. Hi.
Hi, fascinating talk. So I looked on the Michigan Medicine website, and it said that your vision is to create the future of healthcare through discovery and to become the national leader in healthcare reform, biomedical innovation, and education. Do you feel that the current state of your group and its design and its philosophies are an optimal strategy to accomplishing that vision? If you don't feel that that's the case, what do you think that you could do better in that sense?
Great to turn my own words on me. I love it. Well done. I would argue really sincerely that absolutely. But again, part of the point to this, and I think most people, if they just read those words, would think more of that edge and niche. In order to do that, you have to take care of the basic blocking and tackling. You have to take care of the foundation equally. Because if not, you might get your one piece into the environment fine. And it maybe will become very successful, or it may stop working, but many of you won't. In order to achieve that vision, think about that first slide I showed you. I need to focus on those elements on the left side while you focus on the right, and we need to understand each other's point to succeed. My job to achieve that goal are the things that I mentioned. In the absence of that, it will be like the old days where the word was, if you knew the person to get a pizza and a beer, you'll get your code put into one of our systems. That happened occasionally. That's not a way to run a system.
Hi, my name is Brittany Bethune. I work at Seattle Cancer Care Alliance, a cancer hospital, and I actually work in IT. And I'm curious, for the advanced analytics or predictive analytics projects that have been successful at your organization, can you tell us a little bit more about how those got off the ground? So was that a bottom-up thing that came to IT? Was it built with a PI in collaboration with a team from IT? And then also, roughly how long does it take to actually put something like that in practice?
Yeah, great question. It's diverse and it's all over the place, but if I had to try to summarize those themes, the phenotype, if you will, of the successful one is a project that, like you were already talking about in previous sessions, it starts with a use case and example that really is compelling, that cuts across a number of people and divisions and organizations where they say, I see why that's important. It just starts with something that's compelling. But I would say the ones that I think have been most successful are ones where they are working, even an individual is now working within an ecosystem of other people who have knowledge of what I just talked about. At one point, in one way, it helps decrease inertia and friction. But more importantly, it also helps, like I was trying to show you with some of those wireframes, it helps people get to the sources of data that they need to achieve, and that the other people understand what they're trying to do and don't shut them off, cut them off, stop them from what they're doing. The final piece is it also helps, whether it's Brahmaji or Jenna or Sachin or others, where there's some degree of leadership that also says, Andrew, this really is important. I just need to hear that from a few people to immediately know, yeah, that has priority. Why? Because of their role. As opposed to you, I would love to help you, but I don't know who you are. I know who, so sometimes that connection into the organization from the research side also helps those things happen as well.
So give us a sense of scale. How long does it take to get that off the ground? Is it, for those projects you mentioned, is that 2 years in the making?
Yeah.
Is it, yeah.
Andrew, could I follow up? That's a wonderful question. You used the example of Fifth Eye, and I know Fifth Eye really well. And it was always incredible to me, like most of us who make models, let's say, we feel like there's a wall, we throw it over, and we're like, we just made a great model, you guys figure out how to use it. They created an entire software kind of system, right? It was almost like a company within Michigan Medicine to do a lot of those things. What responsibility is it on the PIs and the teams to kind of say, no, you got to not only make the model, but you've got to set up all these kinds of systems in place, or is it the organization's responsibility?
I think there's a variety of that. We actually do help set up some of that kind of thing for investigators who don't have that kind of sophistication. That group, which is MCIRC, really well led by Kevin Ward, hired some extremely talented, technically gifted people like Mark Salamango, who now works for this other company, but at the time was an MCIRC. And we donated 2 of our very best IT staff for 6 months to help that thing set up. One example, but of many, was setting up the Natiza box because they didn't have that expertise. We actually did. Our staff then came back into HITS and they started to build and build and build. And then when Mark said, I don't want to stay on-prem, I need to move off into the cloud, how can you help? I said, we just want to try to give you the U of M financing contracts. You go forward. So there's that mixture of, but that's actually a good example of a variety of groups coming together.
One more question?
Andrew, my name is Chitan from Sanofi Digital Data Science Group. We have similar work as you presented of digital pathology. What our manager told us, great work on the modeling part, but we want to move it into production. So that's out of my comfort zone as a data scientist. So my question is, for the project you presented, what are the steps need to taken from, say, a finalized model for digital pathology to a final product that's hosted in cloud, and different pathologists can upload the image and it can help pathology to analyze the image, give them results. And
how do you move that kind of work into production?
Right.
My best quick answer with the seconds I have, those people that I showed before, you need to be connecting in with those people. Because those people, part of their job is to help move something that, hear me really well, should be moved into production. It's not going to be my choice. It's a collective choice of others. You may say it needs to move in production. With all due respect, it may, but I need other people to say yes or no. They then help, as part of this organization, get into the chains of required getting into production. That is the single best way for you to get your work moving forward, or know the other people in this ecosystem to work with who act as translators, who act as facilitators. That's what's most important. And that, by the way, is my point of the earlier story. When we didn't have that, the answer to your question was absolutely random. Who you knew, and were you lucky? Or were you incredibly persistent or even a jerk and people just finally said, great, we'll get in. Every one of those models worked for people. Now it's a little bit more consistent.
And about the timeline, so I have no experience. So for that project, how long does it take from, say, okay, here's the final model, and until the time that it's become a product, people can use it. So how long usually is that?
Again, it really varies with so many different things. If, for example, it was not designed with assurance, I can tell you how many times people come back and we'll do, for example, you may be working with a vendor, and we have not had that vendor go through our screening. Now the vendor goes through the screening, it's going to take 6 weeks to 8 weeks at a minimum, and if we find problems, you're now delayed. You could have avoided all of that if you went through from the beginning. Things like that.
Okay.
Is there time for maybe one more question?
One more quick question, and
One more quick question. Thank you. And actually, I came from a United States group, and I'm a chief data scientist leading the artificial intelligence. And my group, actually, it is called IT. But currently, we believe all the modernized IT is a combine all the advanced analytics with the emerging technology. So I want to use this time to ask you a question, and also probably for all the audience. So from my practice, we have lots of resources, great talent, and who are very good at the data science, or the other round in the engineering. You know, now the AI is intersection of both. So we really need the talent have the both skill sets.
Right.
So the machine learning and AI is not only produced predictive modeling. Actually, you have to have engineering mindset to provide actionable solution to deliver to your end user. They will know how to use the product to change the world, to make some results. If you only give the model to your end user, they do not know how to do that.
So I think the question may be, and it's a really good one, I was just talking about it with 2 other CIOs yesterday. One of them may be, how do you then change some of your talent to keep relevant? And this is an example. We literally have been talking, that is Justin there, right? I thought it was you before. Justin Pestru was part of a group of us saying, what are the new types of leaders for data within IT that we need in order to stay relevant? And one of the aspects is around, what do we mean by a data scientist? What are the things that we need on that left side of the diagram? That's data science, in order to interact with those people on the right where we are. And that's an example of us trying to stay relevant around the culture, the techniques, and what we have to do around something like data science.
Exactly. Thank you so much.
My pleasure. Thank you.
thank you again, Andrew. You've made a huge impact actually locally here at Michigan Medicine, and I know nationally as well. So thanks again.
Thanks.